We're going to be looking at sigma notation and an example following sigma notation. So sigma notation uses the Greek letter sigma. So it looks kind of like a E. I mean, that's not the best drawing of it. Let me try a little bit better. Go straight, then down, then over, then straight, then E. Kind of like that. And this is known as sigma notation. And what sigma notation alludes to is that we are going to sum a sequence. So sigma notation is the sum. It's shorthand for the sum of n terms of a sequence. And so what we are doing is you would have a sequence of data like 3, 8, 13, values like that will have either a common difference or a common ratio. And you can use this notation to tell the reader or tell the problem solver that we want to add each of those values, those term values. So sigma notation usually has some variable equal to a beginning point. In our case, it's 1, so I is equal to 1 to the number n. These two variables can be any number. This n typically is a finite number. You do end it, but there are situations where this is not finite or infinite, and a to the I. So you're adding every term value from 1 to n. All right, the index I counts through the terms. So the index I counts through the terms in the partial sum. So here we go between the number 1 and n, and we actually count every term value. It's kind of like a bridge having us work up to the top value. And we count every value between 1 and n. So if this is 1 and 3, then what we're looking at, so let's say this is sigma of I equals 1 to, I'm just going to actually go to 4 to get an extra term, AI. This is going to equal A1, so term value A1 plus term value A2 plus term value A3 plus term value A4. So we would be adding or summing each term value between 1 and 4. The value of the ith term is A sub I. You can use the explicit formula for the sequence in place of AI. So if we have the explicit formula, 1 to n, we could use AI minus 1 plus d for arithmetic sequences, or we could use to n a. This is actually, sorry, this is not right. Give me 1 second because I went with the recursive. So this is A1 plus dn minus 1 for this one. And for the geometric, this is going to be A1. And in this case, it's not n. It's I. So we're going to put I there. A1R to the I power, where we have a common ratio. Let me clean this up a little bit. -1, there we go. And so it will just keep counting those sequences. It will keep counting, and you get that term value. Most likely you will not. You will either already have this function or this expression, or you will generate it and then put it into the summation notation. All right, so let's use this in an example. It's easier to use this with actual numbers than with a whole bunch of letters and definitions. So let's look at the summation of I, and sometimes it's a j, sometimes it's a k. It's just a temporary variable sitting there to help us figure out how we are going to add this. All right, so let's say we have the summation between 1 and 9 of 2i minus 6. Okay, so what we're going to do is we're going to find a1. And a1 is going to be 2 times 1 minus 6, which is negative 4. And then we're going to do a2, which is 2 times 2 minus 6 equals negative 2. a3, which is 2 times 3 minus 6 equals 0. And we're going to continue this all the way down to a9 equals 2 times 9 minus 6 equals 12. Okay, now what we're going to do is, I do not have these little periods, but I will fill in the numbers as we do the summation. So this summation from I equals 1 to 9 of 2i minus 6 will then equal a1 negative 4 plus a2 negative 2 plus a3, which is 0, plus a4, which is 2, plus a5, which is 4, plus a6, plus here, a6, which is 6, plus a7, which is 8, plus a8, which is 10, and a9, which is 12. So we're just going to add all these together, and what we find is we find that the summation from I equals 1 to 9 of 2i minus 6 is equal to the value 36. All right. So that's when we have the summation, but let's say we're given something different. Let's say that we're given the series 2 plus 9 plus 16, and this is told that this is a series. So we know we're either going to have a common ratio or a common difference. In our case, it's going to be a common difference because we're working with the arithmetic in this case. So the step 1 for this is to basically find my a1 value, which is 2, my common difference, and if I subtract 9 from 2, I get 7, 16 from 9, I get 7, so on and so forth. So my common difference is 7. And they want us to find the sum, so we actually do need to figure out what happens here. So we do need to figure out how many term values we have in this summation. So I know that a sub n, where it could be any term value, so n term value. And I'm going to use this n for my variable is equal to 79. So this is what we need to find out. We need to find out what term value 79 is. Or sorry, what term number 79 is. All right, so I'm going to use the explicit formula for this. That's the one that says a sub n equals a sub 1 plus the common difference times n minus 1. I know a sub n, we're using 79 for that. A sub 1 is 2, my difference is 7, and here we don't know my n. That's again why this is represented as a sub n. Okay, simplifying and isolating n, what I'm going to find is that n is going to be equal to 12. So we have 12 different term numbers in this sequence of values. The next part, so we found that n equals 12. The next part I'm going to do is I'm going to sum it from I equals 1 to 12. Of here, 2 plus 7 and minus 1. I'm going to simplify this a little, clean it up. And this will be 7, that's negative 7. So 7n minus 5. And again, I just distributed that 7, got -7 plus 2 is -5, and then that 7n goes there. Okay, so using sigma notation, we're going to add all these up. And this looks like a bunch of numbers to kind of add up. I could do it by hand. I can actually use a calculator. TI calculators do have sigma notation. Casio calculators do have sigma notation. Or I can use what's called the sum of series equation. So you have S of n is going to be equal to the n times a1 plus an, in this case, divided by 2. So we're going to do the numbers of terms times the first term plus the last term divided by 2. And this works for arithmetic series. So this is S12 is equal to 12, because that's the number of terms we have, from A1, which is 2 plus 79, divided by 2, and this is equal to 486. And again, we can do this one by hand, or we can use this formula, sum of series formula, to figure out my arithmetic summation. So the series can be written as the sum of 7n minus 5, or 7i minus 5, caught my mistake, so we're using the variable I. And sigma notation, and the sum of this using the summation series formula, sorry, I didn't mean to do a line through there, is 486. All right, just know that there is a summation button on the calculator and that you could use that for these types of problems. All right, guys, so if you have any questions, always feel free to ask, and I will catch you in the next video.